Hello, it's Mrs. Scarpo, and this is Lesson 10. I've got to fill in. This lesson wraps up everything we've learned in this unit on quadratics, the graphing, the factoring, the completing the square for vertex form. So our focus is going to be to choose the most efficient form of a quadratic function, become efficient and accurate in converting from one quadratic form to another, become efficient and accurate in identifying features of the graph of quadratic functions from a given form. So our question is, what information do we get from each form of a quadratic equation, and which form is best for a particular purpose? In our first example, we are given the standard form of a quadratic equation, y equals x squared minus x minus 12. We need to write the factored form and then graph it. So let's start with the factoring. I'm going to use the area model. And we know that in this particular model, we have x squared and we have minus 12 for the number of units. To use the most recent method we've been using for factoring, remember we've been multiplying 1 times negative 12, which equals negative 12. So we are going to be looking for values that multiply to equal negative 12, but that add to equal the b value, the middle term of negative 1. So for 12, we're looking at 1 times 12, 2 times 6, or 3 times 4. If I have 3 plus a negative 4, I will get negative 1 when I add them. 3 times negative 4 gives me negative 12. So I know in these remaining pieces of my model, I will have a 3x and a negative 4x. To multiply to get x squared, that's x times x. And when I multiply x and need to get 3x, I'm multiplying by 3. When I multiply x to get negative 4x, I have to multiply by negative 4. So my factored form is y equals x minus 4 times x plus 3. Now we need to remember that an equation in this form gives us our x-intercepts. In this case, our x-intercepts are 4, 0, and negative 3, 0. When we have our x-intercepts, we can use them to help us find our line of symmetry. We add the intercepts together and divide by 2. So we will have negative, or not negative, but positive 1/2, or x equals 1/2 for our line of symmetry. When we have our line of symmetry, we can find our vertex by replacing x with the value for our line of symmetry. So to find the y value of our vertex, we're going to have 1/2 minus 4 times 1/2 plus 3. That will give us negative 3.5 times positive 3.5, which will equal 12.25. So our vertex is located at 1/2, or 0.5, and 12.25. We can also find the y-intercept by replacing x with 0. So y of our y-intercept will equal 0 minus 4 times 0 plus 3. So that's negative 4 times positive 3 is negative 12, giving us a y-intercept of 0, negative 12. So let's graph. Start by plotting the x-intercepts at negative 3, positive 4. We can mark the line of symmetry, which helps us place our vertex. Vertex is located at 1/2, and that should have been a negative 12.5. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and a little bit more. The y-intercept is at 0, negative 12, and we can put a reflection of it on the other side of the line of symmetry at 1, negative 12. And we can graph our parabola. Remember, this needs to be a curve at the bottom, not a V. Next example, we have y equals x squared minus 6x plus 3. We're asked to write the vertex form. That means we need to complete the square. So I'm going to draw my square. And because it's just a 1x squared, I know I only need one of them. So we have x squared, but because it has to be a square, I know that that minus 6 needs to be divided evenly on both sides. We're going to have x minus 3 and x minus 3, so that we have a negative 3x and another negative 3x. Now to complete this square, negative 3 times negative 3 is 9, but I need to get to a positive 3. So we're going to take 9 and subtract 6 to equal 3. So we have to subtract 6 from this square to give us 3 units. That means our vertex form is y equals, to find the area of a square, it's base times height or length times width. And because they're the same, it's x minus 3 squared. And then we said we also need to do a minus 6. So we can identify our vertex from vertex form. That's why it's called vertex form. And our vertex is going to be at the point 3, negative 6. We can also use the anchor values of 1, 4, and 9. If we take a look at our standard equation, there's no stretch, there's no a value on that x squared term, so I don't need to do anything with these anchor values. Meaning I don't need to multiply them times anything. So when I graph this, I start with my vertex, 3, negative 6, 1, 2, 3, 4, 5, 6. And then on either side of that vertex, I plot my anchor values. So when I go left or right 1 unit, I'm going to go up 1 unit. If I go left or right of my vertex 2 units, I go up 4 units. If I go left or right of my vertex 3 units, I go up 9 units. and then we can draw our parabola. In our next example, we are given the graph and we're writing the equation in vertex form. So I'm going to identify the vertex by looking at the graph. My vertex is at the point 2, -3. I'm also going to look at how do I go from my vertex to another point on my graph by thinking of my anchor values. Now if I go to the right one, I'm not going up a full 1 unit. Looks like it's about half. So I'm going to compare that with my next anchor point. If I go to the right 2, it looks like I go up 2, and 2 is half of 4. So my A value is going to be a positive 1/2. I now have enough information. I can write my equation in vertex form. Y equals x minus 2 squared subtract 3. Remember, in parentheses, that value is opposite what it is at the point. Oops, we need our A value as well, so it's 1/2 times x minus 2 squared minus 3. Now for standard form of this equation, I'm going to multiply out the x minus 2 squared, distribute the 1/2, and then subtract the 3. So I'm going to start with my area model so I can show the x minus 2 squared x times x is x squared, x times -2 is -2x, -2 times x is -2x, -2 times -2 is a positive 4. So now that I've multiplied the x minus 2 squared, I can write a standard form, or start writing closer to a standard form. Y equals 1/2 times x squared minus 2x, -2x subtract 2x is a -4x, plus 4, and then we still have the subtract 3. Before I do anything else, I need to distribute the 1/2. So we will have y equals 1/2 x squared. 1/2 times -4 is -2x. 1/2 times 4 is 2. Subtract 3. And now I can combine the like terms of 2 and -3. So my standard form is 1/2 x squared minus 2x minus 1. Example 4 is asking for the factored form. Factored form identifies the x-intercepts. So I want to first identify my x-intercepts. We have one at the point -7, 0, and we have another at the point 3, 0. We also want to look for that A value. So if I find my vertex and I move to the right one, looks like I'm probably moving down 1/2. So let's compare this to moving to the right 2, and it looks like we're going down 2, and 2 is half of 4. So our A value, because this parabola is reflected, is going to be -1/2. So our factored form is going to be y equals, the A value is -1/2, x plus 7, remember it has to be opposite of what the point is on the graph, times x minus 3. Again, we're being asked for standard form, so I'm going to use my model to help me multiply. X plus 7 times x minus 3 and we have x squared minus 3x for x times negative 3, 7x, and negative 21. So this equation can now be written as y equals negative 1/2 times x squared. Negative 3x plus 7x is 4x minus 21. And just like we did on the last example, we need to distribute that a value. So we will have y equals negative 1/2 x squared. Negative 1/2 times negative 4 is negative 2x. Negative 1/2 times negative 21 is going to become a positive 21/2. And if we look at our graph, 21/2, that's about, I was going to say 10.5, but it looks like my graph is up at about 12.5, so I'm wondering if I made a mistake. I can't see it right now. But this is the process we used in class, and this is the equation we came up with both times. So unless we made a mistake in finding the a value, I'm not quite sure what went wrong here. Number 5 says either form of the equation other than standard form. We also will be identifying the vertex, and we will be identifying x-intercepts and y-intercept. Now I know if I can factor this expression, I can find my vertex, my x-intercepts, and y-intercept from my factored form. So let's go ahead and try factoring this. But you'll notice that this has a negative a value, has a negative x squared. So the first thing I'm going to do is factor out that negative. So I'm taking the distributive property backwards. That will make x squared positive, 6x positive, and 16 negative. And then I can use an area model place my x squared and my minus 16 in it, and I know to get x squared that's going to be x times x. Because I now have a leading coefficient of 1 on that x squared, and 1 times negative 16 is negative 16, I can look for what multiplies to give me negative 16 that is going to add to give me negative 6. Well, factors of 16 are 1 and 16, 2 and 8, 4 and 4. Well, if I want a negative 6, 2 plus a negative 8 will combine to give me a negative 6. 2 times negative 8 will multiply to give me negative 16. So I know I have a negative 8x, and I know I have a positive 2x. When I multiply x to get negative 8x, I'm multiplying by negative 8. And when I multiply x to get a positive 2x, I'm multiplying by 2. So my factored form is going to be y equals, I still have the negative in front, x plus 2, x plus 2, x minus 8. So we can go ahead and identify the x-intercepts from the factored form. Those are negative 2, 0, and 8, 0. I can go ahead and find my y-intercept by plugging in 0 for x. So we'll have a negative 2 times negative 8. So negative 2 times negative 8 is 16. So the y-intercept is 0, 16. In order to find the vertex, we need to know the line of symmetry. The line of symmetry is found by adding the x-intercepts and dividing by 2. So -2 plus 8 divided by 2 is 6 divided by 2 is 3. So the line of symmetry is x equals 3. To find the vertex, I'm going to substitute 3 for the x. So we're going to have 3 plus 2 times 3 minus 5. And we're going to have a -5 and times 3 times -2 is going to be 10. So that means my vertex is going to be at 3, 10. And I'm just kind of pausing in my thought because I want to make sure everything is coming out correct. Oh, I made a mistake. I have a 3 minus 5 instead of a 3 minus 8. Found my mistake. So that's going to change this to -5 times -5. And that's going to give us a positive 25. So our vertex is going to be at 3, 25. In our next example, we have a 2x squared plus 12x plus 13. And again, we're being asked for the vertex and the intercepts. So I'm going to see if I can factor this. I'm going to start by multiplying 2 with 13. 2 times 13 is 26. I would need to find numbers that multiply to equal 26 that are going to add to equal 12. Well, for 26, that's 1 and 26, or 2 and 13. Neither of those will combine to give me 12. So this one isn't going to factor. In that case, we're going to complete the square. So I am going to start by drawing 2 squares because this is 2x squared. And I'm going to put an x squared in each one. Now I have 12x that needs to be split among 4 rectangles that are going to be x, something x. So if I take 12 and divide it by 4, I'm going to get a 3x in each of these rectangles. So that means my dimensions are x plus 3 by x plus 3. That gives me units of 9 and 9 for a total of 18. But I want to get to 13, so I have to subtract 5 from my 2 squares. So my vertex form is y equals, I have 2 squares, so that's 2 times x plus 3 squared minus 5. And now that I have my vertex form, I can identify my vertex, -3, -5. Because this wouldn't factor, that tells me my x-intercepts aren't going to be very nice. I could go through the process of solving this, but it would require some algebra we've not used yet. So I'm not even going to look for the x-intercepts of this particular function, but we can identify the y-intercept. Now I'm going to go through finding the y-intercept by plugging in 0 for x, and then I'm going to point out where you see it in standard form. So if I substitute 0 for x, we have 2 times 0 plus 3 squared subtract 5. Well, that's 2 times 3 squared, so 3 squared is 9 times 2 is 18. Subtract 5 and we get 13. So we have a y-intercept of 0, 13. That also happens to be the c value of our standard form. So the y-intercept is always found at that c value of your standard form. In example 7, we have a leading coefficient of -2. So let's, because again we're looking for vertex, x-intercepts, and y-intercept, let's see if we can factor this by first factoring out a -2. So that's that distributive property backwards. That gives us an x squared minus 7x minus 30. And let's see if we can factor this. So because we have a 1x squared, we want to find what multiplies to give us -30. That will add to give us -7. We're looking at that b value in the parentheses. Factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. Well, I know if I have 3 with a -10, I can get -7, and 3 times -10 will give me -30. So when I factor this, I have my x squared, I have my minus 30, and I know from the numbers I found that I need a 3x and a -10x. That means my factors will be x plus 3 times x minus 10. So my factored form is y equals, we still have the -2, times x minus 10 times x plus 3. And because it's factored form, I can identify my x-intercepts first. They are 10, 0 and -3, 0. My y-intercept I could identify from the standard form is going to be 0, 60. To find my vertex, I would first need my line of symmetry. So I am going to do 10 plus -3, divide that by 2, so we have 7 divided by 2 is 3.5. So I'm going to place 3.5 in for x and solve. So we're going to have y equals -2 times 3.5 minus 10 times 3.5 plus 3. So that's going to be -2 times -6.5 times 6.5. Well, I know 2 times -6.5 is 13. And if I take 13 times 6.5, I'm going to have 84.5. So that means my vertex is 3.5 and 84.5. So some takeaways. It is easier to convert to vertex form when it isn't possible to factor. Vertex form is efficient for finding the vertex and Y-intercept. It is easier to convert to factored form when you can when you have standard form, I should say, and you can complete an area model. Factored form is efficient for finding the x-intercepts. I'm going to say the x and y-intercepts. And the vertex. Standard form is efficient for finding the y-intercept. Some helpful hints for avoiding algebraic errors in factoring, completing the square, or changing to standard form. Draw an area model. So the first part of our retrieval is to do more practice writing in vertex form. So we have x squared plus 12x minus 13. So I start by drawing a square. We have x squared. We know we need to divide that 12x evenly. Half of 12 is 6. So we're going to have plus 6x plus 6x. So that's going to be a plus 6 and a plus 6, which gives us a 36. But we need to get to negative 13. So we're going to subtract 36 and another 13. We're going to subtract 49. So vertex form will be f of x equals x plus 6 squared minus 49. We can do the same thing with number 2. Start by drawing a square. It's going to have x squared, so that we have that x by x. We need to split the negative 8 evenly, so that's negative 4x and negative 4x. So we have x minus 4 times x minus 4, which gives us a positive 16, but we need to get up to 42. So that's going to be plus an additional 26. So our vertex form is g of x equals x minus 4 squared plus 26. And for number 3, we see that we have a 2x squared, so let's do 2 squares. Each of them with an x squared. We have 4 rectangles to divide the 8x, so that's 2x in each. So we will have x plus 2 for the dimensions of our squares. The units on each one will be 4. Now that's a total of 8 units. We need to get to 15, so we need to add 7. So this vertex form is h of x equals 2 times x plus 2 squared plus 7. And finally, we're writing each of these in factored form. So what's going to multiply to give us 56? That adds to give us 15. One times 56, 2 times 28, 4 times 14, and 7 times 8. Well, the only one of those that will combine to give us 15 is the 7 and the 8, if they're both positive. So we have x plus 7 times x plus 8. And finally, x squared minus 5x minus 24. We're going to be looking for what multiplies to give us negative 24. To get 24, we have 1 times 24, 2 times 12, 3 times 8, and 4 times 6. If I use a positive 3 and a negative 8, I'll get a negative 5x. And positive 3 times negative 8 will multiply to give me negative 24. So this factors as x plus 3 times x minus 8. And this is the conclusion of Lesson 10. It is also the lesson that prepares you for the Unit 2 assessment, or the skills needed for the Unit 2 assessment.